In this session, we want to talk about motion under gravity. So in the first video, we were basically talking about when we look at first we have looked at motion that is on the floor, ground to ground. So we are moving from point P1 towards point P2. So this is the first one, but right now we are going to turn it. We are not going to move from ground to ground. We are going to move from somewhere you are on the floor, then you are going up, or you are at the top and you are falling down. So this one we call it motion under gravity. It's also linear motion, but just that it's not happening ground to ground. So how do we tackle that? That will be our concern in this session. When you have a body, let's say, let me put the ground here, and then we are holding a ball over here, and we release the ball. When we leave the ball will fall down on its own, or maybe when you are at the top and then when you jump, you actually go back and falls down. There is a natural force that pulls objects towards the earth. Always there is a force that pushes something down. Always something pushes us down. That force is what we call the force of gravity. Force of gravity. But so wherever there is force, whenever there is anything like force, there is always acceleration. Whenever there is force, there is something called acceleration all the time. Alice, can you mute yourself? If you have a question, then you can unmute and talk. Okay, so whenever there is a force, there is always something like acceleration whenever there is a force. So even when you have a ball on the floor and then you apply a force to it, like you push the ball or you boot the ball, or let's say you shoot the ball, you are applying a force on the ball. And whenever there is a force on something, there's always something called acceleration on the ball because of the force. Whenever there is a force, there is something called acceleration. But the one that naturally occurs under the falling of objects, that natural force, it's also coming, it's because it's a force, it also has an acceleration, and that acceleration is what we call the acceleration due to gravity.
Sir,
Yes.
please, I couldn't see the presentation.
Oh, the presentation is not showing.
Yes, please.
Oh, I think it's, let me stop sharing then let me try it again. Let me know if you can see it.
Yes, I can see.
Okay, sure. Good. So whenever there is a force, there's always going to, you are welcome. Whenever there is a force, there is going to always be going to be a force of gravity, acceleration. But the force that is due to the natural falling of objects, that force is called force of gravity. So the acceleration that is caused by that force is what we call acceleration due to gravity. So that's what we call acceleration due to gravity. So the symbol that we use for it, the symbol we use for it is G. We use the symbol G for that. So whenever you see G, they are just basically referring to acceleration due to gravity. Okay, so how then do we use it in the equations now? So the acceleration we are going to talk about, whenever there is free fall or wherever is a body, either the body is going up or the body is at the top and then we are leaving it to fall down, going up or coming down is going to be always experiencing an acceleration. So in this particular type of motion, we are always giving the acceleration, and it has scientifically, there's an approximated value that has been given for that. At the senior high school, when they don't tell you, when they don't give you the value, for the value for the acceleration to gravity, the value that we give at high school is that you have to know that g is equal to 10 meters per second squared. But if they give it to you, then use the value that they give. Usually they can give you a value like 9.87 or 9.9, or depending on the kind of question they give you. But if the question doesn't give you the value for it, the value, just use 10. This is the general value that we use for acceleration due to gravity. So unlike linear motion where we know all the equations of motion, when it comes to the ones that is up or down motion and is being influenced by force of gravity, there's always acceleration given to us already. So if the question doesn't specify, don't go and be looking for it. It is always given. Now let's revisit all the equations of motion that we had. So let me go to the first one. Okay, so the equations of motions again, we have v equals to u plus at, s is equal to ut plus half at squared, then that's vs, then we have v squared is equal to u squared plus 2as. So these are the equations of motion. So this is equation 1, equation 2, and then equation 3. These are the ones that we have been using so far when we were doing linear motion. But when it comes to the motion under gravity, especially throwing something up or something falling down, free fall, we are going to change some of the parameters. Whenever we call something like acceleration a, we are rather going to use g, because here the acceleration is always known and it is a constant. So that's 10 meters per second squared if it is not provided. So we are going to rewrite this equation. Wherever we see a, we are rather going to put g over there, right? Guys, are you there?
Yes, please.
Good. um so whenever we see s, rather where we have says to deal with distance, wherever we see s, we are going to rather use h. It's the same thing, just that we are now renaming them to match the context that we are facing. Here is talking about height. H is going to be referring to height. H is going to be referring to height. So yes. So those are the two things that we need to change when it comes to equations of motion, either going up or motion coming down. These are the two things that we need to know. So that now it's the same equation, but we are just renaming some of the stuff. A is now G, and then S is now H. So if that's the case, I want someone to give me the three equations again, but with the modification that we need to apply. Who is going to help me? Who is going to help me?
Okay, so for the first equation, we have A equal to U plus GT.
Okay.
And the second equation, we have A is equal to H is equal to UT plus half T squared.
What about the
And
last one?
the last one, we have V squared is equal to U squared plus 2JH. H.
Okay, sure. Thank you very much. Thank you very much. Yeah, that's correct. So let's note that the new differences are going to be just this. We are just changing the G, the A to G, and changing the S to H. But the same thing apply. So wherever they talk about height now, they are not talking about something else. Alice, did you raise your hand? Her audio is lagging, so she might hear it later. Um. Okay. So now we need to apply it to some questions. We need to apply all these to actual questions and see how they come into play. Now, but before that, when you have to keep something in mind that acceleration always is the one that is concerned with signs, negative sign or positive sign. Whenever we are going up, whenever the thing is moving from ground up, right, the acceleration value, the value for acceleration should be negative g, negative g. But if you are going already moving from top to down, the value for the acceleration to positive g, positive g. That's what you need to keep in mind. Whenever we are going from ground to top, it's going to be negative g. If it's going from top to down, it's going to be positive g. Why is that so? We say that the force of gravity is always pointing towards the ground. The force is always pointing towards the ground, and that force is the one causing the acceleration. So if you are throwing something up, it's as if you are throwing it against the force, the natural force. You are throwing the g. Let me mute her. So it's as if you are already throwing something against the natural force g. For that reason, the g, when you are going up, you consider the g to be negative because you are going against the force of gravity. But if you are going from top to down, then it's already in the direction of the natural force, so it become g is positive. So let's just keep it like that. So when we are analyzing the various cases, we don't need to just change the values, but we also keep in mind, are we going up or we are going down? Is that okay? Is that okay?
Yes.
Sure. So now let's look at the first question. So this is the first question. A ball is dropped from a height of 20 meters. So we have to write our parameters as usual. So height is equal to 20. How long does it take? How long? So how long is going to be? They are looking for the time. How long does it take to reach the ground? Yeah, we have H and G. So let's look at some of the things that we need to note for such a question. So we have three equations already. So we have, and then always whenever something is given like this, we already know that G is, they have not given G, so the value for G is 10 meters per second squared. Whenever there is throwing up or throwing down, the acceleration is already given, always given. Have to keep that in mind. So we know we have acceleration, we have S, and then we don't have G. So now the thing is, which equation are we going to use? Which equation are we going to use? So we have V is equal to U plus GT. This is what we have. This is what we have. A ball is dropped from a height. So if you have something like this and you are dropping it, if you are dropping, whenever you are dropping something from a particular height, you are just dropping it. So you are not applying any velocity. So at the beginning, the initial velocity is zero. Whenever there is a dropping or leaving something to fall from a particular height to the floor, whenever you are just releasing it at a particular level to the top, to the floor, U is always zero. Initial velocity is zero. So these are the hidden parameters that you need to extract before you start choosing your equations to solve. Okay, is that clear?
Yes, sir.
Okay, so now let's see which equation we are going to use now. Now that we know those stuff, so we know S. Oh no, it is now going to be H. H is equal to UT plus half GT squared. The value for G, is it going to be positive or negative? Is the G going to be positive or negative?
Positive.
Why?
Because it's heading towards the ground.
Okay, sure. Now we are looking for T. Oh, 2GH rather, 2GH rather. Now we are looking for T. So now let's go to the first equation. Do we know V? V was not given to us. U was given to us, which is 0. G was given to, is already known, and T is not given to us. So there are two unknown in this equation, so we are not using that. H was given to us. We know U. We know we don't know T. We don't know T. So we know G. So T is the only parameter that is missing. Right? So can we select this equation to be the one?
Yes.
Okay. So put in the values and tell me what you get. Let me also try something here. And then
Add T to 2 seconds.
T to be 2 seconds. So T should be equal to 2 seconds. So let's see how you did it. So we know that H, so we have H is equal to UT plus H half GT squared. Okay. So this one is 20 equals to 0 times T plus half G is 10, 10 and T squared. So 0 times T here is going to be 0. So it's going to be left with 20 is equal to 5 times T squared. So if you solve this, we are going to have T squared equals to 20 over 5. 20 over 5. And then in that case, square root of both sides, T is equal to square root of 20 over 5. That will be 4. That will be 4. T is equal to plus 2 or negative 2. But then if you are doing that, we are just focused, time cannot, we are not focusing on the negative sign. We are to T is equal to 2 seconds. 2 seconds. So the time is 2 seconds. That's correct. So you had it correct. Let's look at another question. I have a lot of questions here today too. Yeah, so this one, a stone is thrown vertically upward. So you are going to tell me all the parameters that we can extract from this question too. So a stone is thrown vertically upward with a speed of 15 meters per second. How high does it rise? How high does it rise? So
Hello.
yes,
Hello.
yes,
Hello.
yes, Alice, can hear you. Do you want to attempt? I can hear you. I think it's network issues. What are the
Okay.
parameters?
So my first parameter, I got the acceleration due to gravity to be negative 10 meter per second square,
Why negative 10?
because the person is throwing the ball vertically upwards and is opposing the force of gravity.
Okay, yeah, that's correct.
Then my initial velocity is 15 meter per second.
So that's you, right?
Yes.
Okay.
I'm a boo boo.
And since the ball is going to rest in the air,
Mm-hmm.
so my final velocity will be 0 meter per second.
Okay. So a stone is thrown vertically up with a height. How high does it rise? So yeah, so you said V equals to 0 meters per second. Okay. Now this is the thing. I want to iterate on that, reiterate on that. When you throw something up, you see that the thing goes from the from the floor to the top and then gets to a point where it's temporary stops. Can you hear me?
Yes, please.
Think. Yeah, let me see. I'm trying to. Okay, sure. So if it goes up temporarily, it gets to a point where it stops and begins to return. At that point where it begins to stop, that point is called the maximum height, or where how high the highest that it can go. So this is the maximum height. So we can call it H max, the or the maximum that it can go. At that level, the all the velocity that you have given it, all the velocity has finished. So it has all gone to zero. So at that maximum height, the final velocity V is equal to zero. And I like that you're able to point that out. So at the beginning we give it 15, but when you reach a maximum height, it's the velocity is zero, because at the maximum height the body will begin to finish all its velocity, and now we'll try to start its journey back down. So yeah, that was very good. That was very good. So yeah, let's solve this one. So which equation are we going to use? We are looking for h. So which of the equation are we going to use?
We are going to use the third one.
You mean v squared?
It's equal to u squared plus 2g.
2gh. Okay, so what do you get? What do you have? Let's put in the values. So v squared, so that's like 0 squared is equal to u squared is 15 squared plus 2 times 2 times negative 10 times h. So it is this h that we are looking for. So it become negative 15 squared equals to negative 20h. So our h will be equal to negative 15 squared. That will be what on your calculator?
225.
Negative 20. Yeah, so become negative 225 over negative 20. All the negative will cancel out. So our height will be equal to what?
11.25 meters.
25 meters. Good, 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 good. Yeah. So that's, are you able to link that? Have you seen how this thing easily connects to the one that we learned last time?
Yes.
Yeah. So that's how the things are related. That's why we have to actually take time to understand the basics. This one, the same thing is going to be relating to the next concept that we'll be learning, like that in that order. So I have some questions here that I still have some questions I want to try. I want you to try, right? So here you are going to basically be the one to lead me through that discussion. I think I didn't save anyone in that section. Okay, I think I saved one here. Here I have only one value. I have only one value. So when you are ready to take me through all the steps, let me know.
Okay, so I first take my acceleration due to gravity to be negative 10 meter per second squared.
Okay.
Then I take my initial velocity to be 20 meter per second.
Mm-hmm.
Then my final velocity will be 0 meter per second,
Why is it zero?
because when the ball is thrown upwards, it's going to stop mid-air before it comes down. And when it stops, the velocity is 0 meter per second.
Okay.
Then they said they are looking for the height.
Oh,
So for
oh
the
shit.
you can use the
Mm. We are using
the
what?
third the third equation,
Which
which
is
is v squared is equal to u squared plus 2gh.
so let me replace the values. So and see what we have. U squared, that was 20 squared plus 2 times negative 10 h. So then I'll have negative 400. 400, right? Negative
Yeah,
20h. So h will be equal to 400 over 20. So this the answer will be 20. Is that correct?
yes, please.
Yes. So we have h is equal to 20 meters. Yeah, someone is raising their hand.
No,
You said?
it was a mistake. It was
Okay,
a
sure,
mistake.
sure, sure. Yeah. So the last question that I have in my package is this one. With the speed of 10, how long will it be in the air before hitting the ground? So before we do this, let me take, if you are throwing something into the air, hey shit, what's that? That's horrible. That was very, very horrible. So if you throw something into the air, if you throw something into the air, and then so it goes up, and then we like to, oh, the thing goes up, then begin to fall down. The time that you spend going up is the same time you spend going coming down. If listen to the if very well, the time that you spend going up is going to be the same time coming down if the body falls at the same level on the ground. If the body falls at the same level on the ground. So again, they said the time that you, if you calculate the time to reach the maximum height, yeah, let's say it's t, it's going to take the same time to fall down, if so t1 t1 is going to be equal to t2 if they fall at the same ground. But if you have something like this, the floor is here, the floor is here, then there is a table
Hmm.
here.
Hello.
Yes, hello.
Please,
Alice.
I can't see the presentation.
Okay, sure.
So,
Let me stop and then share again. Let me stop and share again. Let me know if you can see it now.
no, please.
Wait a bit. What about now?
No, please. This
Okay.
whole time I've been you didn't hear me.
Oh, I didn't hear you. Sorry. So can you leave the call and join again?
Okay.
Sure. Yeah, so if there is something on the floor, like you throw something from this floor, you throw it up and it falls rather at this level, you see, it's not coming back to the same starting position or starting level. So you cannot make that assumption because the time taken to reach maximum height is not going to be the same time taken to for the body to land where it has landed because the levels are different. The levels are very different. Does that make sense?
Yes, please.
Okay, sure.
Yes.
Sure. So the easy thing is that for the time that this body will be in the air, will be, so you have to first calculate the time that it will take to reach the maximum height. Then if that time is t, then you just multiply by 2 to get the total time that it will come down because it will go with the same time up and use the same time to come down. So if you multiply by 2, then you just have the total time. That total time, let's use capital T for it. So capital T is equal to 2t. So this one only holds if the body falls at the same level where it started from. That's the assumption. So let's keep that in mind. So analyze the question and then tell me how we are going to go about it.
Okay. So for this question, we still have our acceleration due to gravity to be negative 10 meter per second square.
So g is equal to negative 10 meters per second squared. Has Alice come
Then,
back? Wait, let me see.
Yes, please.
Can you see the presentation now?
Yes, please.
Good, good, good. So now you say g is equal to 10 meters per second. I'm listening. Continue.
then our initial velocity will be 10 meter per second.
So u is equal to 10. That's from the question. Okay.
Yes. Then our final velocity will be 0 meter per second.
0 meter per second.
And now we are looking for the time it takes. How long will it be in the air before it hits the ground? So first, we are going to calculate the time it took to reach the air.
Okay. Sure. So that's
So,
small t,
but
right?
yes,
So which equation are we using?
we are using the first equation, which is v is equal to u plus dt.
Okay, sure.
Then when we substitute, we have 0 is equal to 10 10 minus 10g, 10t.
Okay.
Then we shift the 10 to the left hand side. Then we divide through by negative 10.
So we have t will be equal to 1
Yes, one
second.
second.
Is that all?
You said the answer we get, we multiply it by 2. So the big T will be equal to 1 second times 2,
So the answer will be
which
two
will be,
seconds.
yes.
Okay. Yeah. So this is the time of flight or time spent in the air. 2 seconds. Okay. So yeah. Um Alice, can you hear me?
Yes, please.
Okay. So I've recorded the video as usual. I will make sure that this time I post it very early so that you watch it and all of you watch it. Then tomorrow I'm going to bring more question, more challenging question. What we have done so far, it has been the basics to make sure we are able to master the equations and how to plug them and link it from the previous one. Once we
Okay.
Yes, once we you watch the video, go through all of them, how to choose the equations, how to put this and that. Tomorrow we are just going to be solving questions, solving questions. So let's prepare ourselves for that. Okay.
Okay, sir.
Yeah. But so far, do we have any question?
No,
Sir,
please.
please, can you solve another example?
Yeah, the examples that I've brought, all the examples have finished. But the good thing is that I've recorded them. So if you watch them and you see how we've solved it and I explain it, if it doesn't make sense tomorrow, when we solve more questions, then you can ask. Do you understand?
Okay, sir.
Sure. So let's see tomorrow how your understanding so that we can help you catch up quickly. Um okay, so Kennedy has been able his network has been stable for a while. So Kennedy, do you have what is the new thing or something that was very that helped you to figure out things in this session? I mean something new.
Okay, so to my observation, I was able to detect that for the motion under gravity, we have our distance to be equal to height, which makes sense because with the distance can be measured with using the length, either the length, width or height. So when the distance is replaced by height, it makes sense.
Oh, okay.
Also, our acceleration was changed to acceleration due to gravity because with the motion under gravity, the acceleration that follows the force acting on the object is called acceleration due to gravity. And when it is going up, the acceleration is due to gravity is negative because it opposes the force of gravity. But when it is going down, it is positive because it follows the force of gravity.
Good. So basically you're able to draw that connection between the previous one and the previous type of motion and the current type of motion. Is that the case?
Yes.
Good, good, good. So Alice, let's catch up tomorrow, okay?
Okay, sir.
Okay.
Yeah. So tomorrow bring your calculators, let's solve. So watch the videos and then also remember to share so that people can also get in touch. Are we okay?
Yes, please.
Yeah.
Yes.
Thank you and good night everyone.